Find the perimeter of each polygon. Assume that lines which appear to be tangent are tangent. So, for example, this line segment here is tangent to the circle, and this line segment here is tangent to the circle. We know by the two tangent segment theorem that since those intersect, those two tangent segments intersect, they create congruent segments. So this should also be 14. You also know that this whole length right here is 23, but this right here is 14. So we know the remainder must be 9. So this is 9. I'll use a different color. Right here is 9. Since this is 9, this must also be 9. And since this whole thing right here is 22.7, 22.7 minus 9 is going to give us the remainder of that segment, which is 13.7. Should have been able to do that in my head. 13.7. And if this is 13.7, then we know that this is also 13.7. So you can either add up each and every segment, like 9 plus 13.7 plus 13.7 plus 14 plus 14 plus 9, and so on, or you can just say, well, I know this whole side is 23. I know that whole side is 22.7. And then I also know that this one is 14 plus 13.7. Let's see if this will calculate. 73.4. Okay. Now for this question, same thing going on here. If this is 5.4, we're assuming those are tangent segments, then that means this is also 5.4. If this is 5.4, and that whole thing right here is 18.4, then this should be, right here, should be 13, right? That means this one is also 13. Now if that whole thing is 13, or the whole thing is 21.9, but that part of the segment is 13, then we just do 21.9 minus 13. So this right here is 8.9. If that's 8.9, then this is 8.9. If this whole thing right here is 20.5, and that little bit is 8.9, then we should end up with a remainder here of 11.6. And that means that this also is 11.6. Okay, we have all the sides now, and all we have to do is add them all up. So 18.4 plus 21.9 plus 20.5 plus 5.4 plus 11.6. Let's see if that'll give it to us. Okay, looks good. 77.8, that's what I'm getting, so 77.8.